Hello guys, welcome to another video here on cross-site scripting. It's under the Web Fundamentals learning part here on Tryhackme, and we're currently studying the introduction to web hacking module. Without further ado, let's hop on to it. Task 1. Before that, we're going to learn how to detect and exploit XSS vulnerabilities, giving you control over other visitors' browsers. Okay, now task 1, room brief. The prerequisite here is that it's worth noting that because XSS is based on JavaScript, it would be helpful to have a basic understanding of the language. I don't, but however, none of the examples is overly complicated. Also, a basic understanding of client-side requests and responses is needed. Okay, now cross-site scripting, better known as XSS in the cybersecurity community, is classified as an injection attack, where malicious JavaScript gets injected into a web application with the intention of being executed by other users. Now, in this room, you will learn about the different XSS types, how to create XSS payloads, how to modify your payloads to evade filters, and then end with a practical lab where you can try out your new skills. Okay. Now, cross-site scripting vulnerabilities are extremely common. Below are a few reports of XSS found in massive applications. You can get paid very well for finding and reporting these vulnerabilities, like the XSS found in Shopify, the $7,500 reward for XSS found in Steam chat. You can check that out on the HackerOne reports here. Usually you'd see how the person who dictated it and more like the details of the vulnerability exploit. Now, and so on, basically. So answer the question below. What does XSS stand for? We have that as the cross-site scripting. Cross-site scripting, right? And that's correct. Task 2, XSS payload. What is a payload? In XSS, the payload is the JavaScript code we wish to be executed on the target's computer. There are two parts to the payload: the intention and the modification. And the intention is what you wish the JavaScript to actually do, which we'll cover with some examples below. And the modification is the changes to the code we need to make it execute, as every scenario is different. More on this in the perfecting your payload tags. Okay. Now, here are some examples of XSS intentions. Proof of concept. Now, this is the simplest of payloads, where all you want to do is to demonstrate that you can achieve XSS on a website. This is often done by causing an alert box to pop up on the page with a string of text. For example, the script, which is the beginning of JavaScript code here, alert, then the XSS, and then the closing code here. All right. The second is the session stealing. All right. Details of a user session, such as login tokens, are often kept in cookies on the target machine. Now, the below JavaScript takes the target's cookie, base 64, encodes the cookie to ensure successful transmission, and then posts it to a website under the hacker's control to be logged. Now, once the hacker has these cookies, they can take over the target session and be logged as that user. Now, the code is more or less like the script, starting the script, then it's going to have like fetch, then the hacker's domain, and then steal cookie plus BTOA, document cookie, and so on. Okay. The third is keylogger. The below code acts as a keylogger. This means anything you type on the web page will be forwarded to a website under the hacker's control. And this could be very damaging if the website the payload was installed on accepted user logins or credit card details. Now we have the code looks like the script, of course, and then document.onKeyPress equals to the function E, then fetch the hacker's domain, then /log key equals to btoae.key, and then ends with the script code. Business logic. Okay, now this payload is a lot more specific than the above examples. Now, this would be about calling a particular network resource or a JavaScript function. For example, imagine a JavaScript function for changing a user's email address called user.changeEmail. Your payload could look like this: the script, the user.changeEmail, then the attacker's email, and then the script. Now, the email address for the account has changed. Now, the attacker may perform a reset password attack and get access to that particular website or session. Now, the next 4 taxes are going to cover the different types of XSS vulnerability, all requiring slight different attack payload and user interactions. Before we do that, what document property could contain the user sections token? Okay, it's more or less the document.cookie. So basically, document.cookie. That's it here, right? Yeah, I can copy that from here. Document.cookie. I'm just going to copy that. That answers this. Hit submit. Correct. Which JavaScript method is often used as a proof of concept? It is the alert. Okay, it is the alert. Correct. Now, task 3, reflected XSS. Now, reflected XSS happens when user supplied data in a HTTP request is included in the web page source without any validation. Example scenario here: a website where if you enter incorrect input, an error message is displayed. The content of the error message gets taken from the error parameter in the query string and is built directly to the page source. So we have something like the website domain, then we see the parameter here, which starts with the query string error equals to invalid input detected. Now, the application doesn't check the contents of the error parameter, which allows the attacker to insert malicious code. So basically, that's one of the parts where they use the XSR in reflected XSS. So basically, that's where they take advantage of the reflected XSS, because basically the application doesn't check the content of the error parameter, right? Okay, now the vulnerability can be used as per the scenario in the image below. So we have attacker sends a link to a victim that contains a malicious payload. Now the victim clicks the link and is taken to a vulnerable website, which looks like this, of course. Now the link containing attacker script is executed on that website and is brought back through the victim back to the attacker. Now the data the attacker script gathered is sent to them. They could steal the victim's cookie, which would allow the attacker to take over the victim's account. Okay, now the potential impact here is that the attacker could send links or embed them into an iframe on another website containing a JavaScript payload to potential victims, getting them to execute code on their browser, potentially revealing sessions or customer information. Now, how to test for reflected XSS? You need to test every possible point of entry. This includes the parameter in the URL query string, the URL file path, and sometimes HTTP headers, although unlikely exploited in practice. Once you've found some data which is being reflected in the web application, you will then need to confirm that you can successfully run your JavaScript payload. Then your payload will be dependent on where the application your code is reflected. You will learn more about this in task 6, wherein an URL is a good place to test for reflected XSS. That should be the URL parameters, so it's not usually checked. Parameters. Correct. Let's head on to task 4. Stored XSS. Now, as the name infers, the XSS payload is stored on the web application in a database, for example, and then gets run when other users visit the site or web page. Now, example, a scenario, a blog website that allows users to post comments. Unfortunately, these comments aren't checked for whether they contain JavaScript or filter out any malicious code. Now, if we now post a comment containing JavaScript, this will be stored in the database, and every other user now visiting the article will have the JavaScript run in their browser. So we have an example scenario here and diagram here, attacker inserts the malicious payload into the website's database. Okay, now for every visit to the website, the malicious script is activated, and which can gather the victim's data, where the data of the attacker's scripts gathered, where the data the attacker's script gathered is sent to them. They could steal the victim's cookie, which would allow the attacker to take over the victim's account. Potential impact. Here the malicious JavaScript could redirect users to another site, steal the user's section cookie, or perform other website actions while acting as the visiting user. Now, how to test for stored XSS. You need to test every possible point of entry where it seems data is stored and then shown back in areas that other users have access to. A small example of this could be comments on a blog, user profile information, and website listing. Sometimes developers think limiting input values on the client side is good enough protection. So changing values to something the web application wouldn't be expecting is a good source of discovering stored XSS. For example, an age field that is expecting an integer from a drop-down menu, but instead you manually send the request rather than using the form, allowing you to try malicious payloads. Now, once you found some data which is being stored in the web application, you would then need to confirm that you can successfully run your JavaScript payload. Your payload will be dependent on where the application your code is reflected. You will learn more about this in Task 6. How are stored XSS payloads usually stored on a website? Usually on the database. That submit incorrect. Task 5. DOM Based XSS. Now, what is DOM? DOM stands for Document Object Model and is a programming interface for HTML and XML documents. It represents the page so that programs can change the document structure, style, and content. A web page is a document, and this document can be either displayed in the browser window or as the HTML source. A diagram of the HTML DOM is displayed below. So you have the document, the root element, which is the HTML, which is spread into two. So something like this, of this nature. Now, if you want to learn more about the DOM and gain a deeper understanding, the w3.org has a great resource. Now, exploiting the DOM. DOM-based XSS is where the JavaScript execution happens directly in the browser without any new pages being loaded or data submitted to the backend. Executions occur when the website JavaScript code acts on input or user interaction. Example scenario. Now, let's say the website's JavaScript gets the content from the window.location.hash parameter and then writes that onto the page in the currently being viewed section. Now, the contents of the hash ends checked for malicious code, allowing an attacker to inject JavaScript of their choosing onto the web page. Potential impact. Crafted links could be sent to potential victims, redirecting them to another website or steal contents from the page or the user session. How to test for DOM-based XSS. DOM-based XSS can be challenging to test for and requires a certain amount of knowledge of JavaScript to read the source code. You need to look for the parts of the code that access certain variables that an attacker can have control over, such as the window.location.x parameters. Now, when you found those bits of code, you would then need to see how they are handled and whether the values are ever written to the web page DOM or passed to unsafe JavaScript methods such as eval. Now, what unsafe JavaScript method is good to look for in the source code? We just talked about that. So that's eval, right? Place that and hit enter. Correct. Let's head on to task 6. Blind XSS. Blind XSS is similar to the stored XSS, which we covered in task 4, in that your payload gets stored on the website for another user to view. But in this instance, you can't see the payload working or be able to test it against yourself first. Example scenario. A website has a contact form where you can message a member of staff. The message content doesn't get checked for a malicious code, which allows the attacker to enter anything they wish. Now, these messages then get turned into support tickets, which staff view on the private web portal. Potential impact. Using the correct payload, the attacker's JavaScript could make calls back to an attacker's website, revealing the staff portal URL, the staff members' cookies, and even the contents of the portal page that is being viewed. Now, the attacker could potentially hijack the staff's members session and have access to their private portal. Now, how to test for blind XSS? When testing for blind XSS vulnerabilities, you need to ensure your payload has a callback, usually an HTTP. This way you know if and when your code is being executed. So a popular tool for blind XSS attacks is the XSS Hunter Express. Although it's possible to make your own tool in JavaScript, this tool will automatically capture cookies, URLs, page contents, and more. What tool can you use to test for blind XSS? Okay, we just mentioned this, the XSS Hunter Express. Use that to test for the blind XSS. Correct. What type of XSS is very similar to the blind XSS? It's the stored XSS. The only difference is the blind XSS, you won't be able to see the results of your payload on the hacker's page or website or tool and that's that. Let's head on to task 7. We're going to start this machine because we'll definitely need that. Now, the payload is the JavaScript code we want to execute either on another user's browser or as a proof of concept to demonstrate a vulnerability in the website. Your payload could have many intentions, from just bringing up a JavaScript alert box to prove we can execute JavaScript on the target website, to extracting information from the web page or user session. Now, how your JavaScript payload gets reflected in a target website's code will determine the payload you will need to use. To explain this, click the green Start Machine button on the right. We've done that. And when the machine has loaded, open the link or open the below link in the new tab. So it will be ready in 7 seconds. Now, the aim for each level will be to execute the JavaScript alert function with the string THM, for example. Okay, let's quickly do that. I think my IP address is ready, so I'm going to open this link in a new tab. It's loading, and let's quickly see. Level 1, I guess. Okay. Home is ready. We have level 1. Let me increase this a little bit, and we're good to go. Now, level 1, you're presented with a form asking you to enter your name, and once you've entered your name, it will be presented on a line below, for example. So you say enter your name. Let's just do that quickly. So you say Amy, and I hit enter, and it says hello Amy. So confirming the XSS payload is going to say no, XSS payload failed because we just entered our name. We didn't enter a JavaScript payload. So if you view the page source, you will see the name reflected in the code. So let's quickly do that. Ctrl U. So scroll down a little bit. You can see what part is it? Yeah, basically here you see text center hello Amy. So it's reflected in the code. And let's go back here. Basically, now instead of entering your name, we are instead going to try entering the following JavaScript payload: the script alert THM, and end the script, and then end the quotation of the code, which is the backend / script. Now, when you click the enter button, you get an alert pop up with the string THM, and the page source will look like the following. Where you have the alert, the THM, basically, and then you would get a confirmation message that your payload was successful with the link to the next level. All right, so I'm going to copy this script code just to make it easy. Going forward, I might just be able to write it myself. So paste that, hit enter, and you see we got success THM, and let's see. go to level 2. But before that, if you click on Ctrl U, if you scroll down a little bit, you're going to see how our script was executed. So hello, you see the script, alert THM end of the script being in between this part. So close this, let's go to level 2. All right, level 2. Like the previous level, you're being asked again to enter your name. This time, when clicking enter, your name is being reflected in an input tag instead. Okay, so we have like an input tag in this case. So let's click Amy and hit enter. Right, let's see. So we see hello. There's an input tag here, like a name input tag, but it will tell you the payload is not, failed. Yeah. Now, basically after doing that, if you view the page source, you can see the name reflected inside the value attributes of the input tag. So you have like, let me Ctrl U here so you can see that. So scroll down a little bit, increase. So you see value, then you see like a name tag, an input tag right here. So there's an input tag compared to the other level 1 example. Right now, so it wouldn't work if you were to try the previous JavaScript payload, because you can't run it from inside the input tag. Instead, we need to escape the input tag first, so the payload can run properly. Now, you can do this with the following payload. We need to more like a way of closing that input tag and allowing our script to run by just adding the important part of the payload is the quotation mark and the right arrow, which closes the value parameter and then closes the input tag. Now, this now closes the input tag properly and allows our JavaScript payload to run. So just copy that and Ctrl C, go to there and paste it here, enter, and there we have a successful XSS attack there. All right, and if you click Ctrl U, if you scroll down a little bit, if you look here, you can see here that we have the input. That this closes that input tag, this quotation mark, and this makes it complete, and this was able to execute. So here, close to go to level 3. What does it say here? Now, when you click the enter button, you get an alert pop-up with the string THM, and then you get a confirmation message that your payload was successful with a link to the next link. Hold on that. Now, level 3. You're presented with another form asking for your name, and the same as the previous level, your name get reflected inside the HTML tag, this time the text area tag. So this time we're having a text area issue, so I'm going to just type Amy, hit enter. If we enter, you see we have like a text area tag here. I'll Ctrl U this, and then if you scroll down a little bit, you see we have like a text area tag where we have Amy in between. So we're going to develop a payload for that. Let's go on. We could see now we have to escape the text area tag a little different from the input 1 in level 2 by using the following payload. You just use the text area here, which you close the other text area code, and then that particular script. Right, this turns this, basically this turns this, which is the initial one we have, into this, where this text area closes this text area and have our script run, making this particular one invalid. Right now, the important part of the above payload is the left arrow / text area, which causes the text area element to close so the script will run. Now, when you click the enter button, you get an alert pop-up with the string THM, and then you get a confirmation message that your payload was successful with the link to the next level. So I'm just going to paste that, just complete that level, and there we go, success. Okay, it's going to load up. Let's go to level 4. Good, level 4. All right, on level 4 here, entering your name into the form, you will see it reflected on the page. This level looks similar to level 1, but upon inspecting the page source, you will see your name get reflected in some JavaScript code. So we have a JavaScript code issue here on this one. So click enter, and payload failed. Ctrl U, shortcuts to the source page. Here, scroll down a little bit, zoom in a little bit. You see that we have a JavaScript code here where we include our name here, where it's now the .inner HTML Amy. So what do we do in this case right now? Basically, in this case, we'll see you will have to escape the existing JavaScript command, so you'll be able to run your code, you can do this with the following payload that starts with this command, then alert thm ends with this 2///, which you will see from the below screenshot will execute your code. The closing quotation here, the single closing quotation here, closes the field specifying the name. Then the semicolon here signifies the end of the current command. And the ///, // at the end makes anything after it a comment rather than an executable code. So we're going to try that and let's see what happens. Okay, I'll copy this and Ctrl+C, come over here and paste that, enter, close this first. We're successful. And once we've done that, I'm going to Ctrl U, and if I scroll down a little bit, let's see what happened. So you basically see, so you can see what the code did. So we have the single quotation here ending the more like the code, and this semicolon to end the whole code running from this part to the end of this part, and then the alerts, which is now our payload executing, and also the double / here to end, make anything that comes here just like a comment. So making this alerts thm code to run properly. Right, so let's head on to task 5, close this, and task 5, level 5 actually. Now this looks the same as level 1, and your name also gets reflected in the same place. But if you try the script alert thm script payload, it won't work. When you view the page source, you will see why. Let's try that quickly. If we say first, let's see the AMI. If I use that, I want to see what happens or how the payload looks like. And then Ctrl U, let me see, scroll down. Okay, see where hello, there's a command, there's AMI, but it looks like the first one. But if you use that code, let's see if we use the code. So let me write this code myself now. So we have script, right, and right arrow. You have the alert, open bracket, quotation here, thm, cover brackets, and then close script, then end our JavaScript code with left arrow / then script. I know this is already there, but I just want to familiarize myself with the code. And then the right arrow, hit enter, and it's wrong. Let's open this and see why. If we open this code, if you scroll down to this part, what happened? So we saw more like, oh, I see. So we see what happened in this code. Let's read more about it here. So the word script gets removed from your payload. Did you notice it? All right, you see there's no scripts. There are no scripts inside your payload. Okay, it's got removed. All right, now that's because there's a filter that strips out any potential dangerous words. When a word gets removed from a string, there's a helpful trick that you can try. Original payload looks like this. Yes, script. Oh, this is the original payload. Text to be removed by the filter when you've used that payload, and then the final payload after passing the filter will now have that left. So we're just adding, basically we're adding script in between this particular script. So we're basically adding scripts inside the script just after S. So basically that's what happens. So let's copy that and let's see what happens. Enter. And there we go. All right, so if we Ctrl U now, we should be able to see that it executed script even after the filter. So let's go to level 6, but before then let's conclude this. Try entering the payload, which you already did, and click the enter button. You get an alert pop-up with the stream thm, and then you will get a confirmation message that your payload was successful with the link to the next level. We've done that. Level 6. Similar to level 2, where we had to escape from a value attribute of an input tag, we can try this particular code or the payload, but that doesn't seem to work. Let's inspect the page source to see what happens. So let's copy this, which was the initial one, and let's see what the issue is. Oh, we can see it, level 6 is using an image path. Click enter, you see it pops up an image, right? Let me control U first. If I scroll down a little bit, you can see it now involves value, but has an input like a location path here. Let me close all this, and let's try using that level 2 payload. If I do that, it will definitely fail. Then control U, let's see what happened to our payload. So as you can see what happened in our payload, let's read more about that. Okay, now you can see that the left arrow and right arrow characters get filtered out. Okay, let's look at that. Okay, yes, the left arrow and the right arrow got filtered out. Okay, and preventing us from escaping the image tag. To get around the filter, we can take advantage of an additional attribute of the IMG or the image tag, such as an onload event. The onload event executes the code of your choosing once the image specified in the SRC attribute has loaded onto the web page. Now let's change our payload to reflect this. So we have this, but we had added the image location. Then we're going to use the onload event basically, and then viewing the page source, you will see that this works. So let's try that. Control this, Control V, enter while it's loading, and close this, and we had a success. We have that success. Okay, and if we Control U, let's see what happened there. So using that onload, after the image loaded successfully, the onload was able to help us to execute our code right there. And we can see here, now when you click the enter button, you get an alert pop-up we just did, and you get a confirmation to enter the last level. So let me scroll down. Successful. Oh, it looks like this might be an answer to a particular. Let's see if that, I'm supposed to answer a question with that, right? What is the flag you received from level 6? I thought as much. Let's just copy that and answer that question. But before then, let's just complete the last option here. So polyglots. An XSS polyglot is a string of text which can escape attributes, tags, and bypass filters all in one. You could have used the below polyglot on all 6 levels you've just completed, and it would have executed code successfully. Wow. So let's try that. I'll copy this polyglot, copy Ctrl C, come over here and Ctrl V, enter, and wow, it did work. Okay, it did work. Great. Interesting. So I'll just copy this flag here to answer the last question here, and we're done with tax 7. Successful. Close this and close this. Let's head on to tax 8, the final tax here. So it looks like we're going to use a new machine here. I'm going to terminate the old one. Once we've done that, I'll start the new one here. Now for this tax, we'll go over a blind XSS vulnerability. Ensure you terminate the previous machine. I just did that, and then click on the green start machine button on the right to load the ACME IT support website. You will need to use the attack box using the blue button at the top of the page. Once loaded, open the link below inside the attack box Firefox browser to view the target's website. So I might be using my machine because I'm connected with the OpenVPN. So once this is ready, I'll open the link, and now let's see what we're going to do once that is ready. We're going to click on the Customers tab on the top navigation bar, and then click on Sign Up, link to create an account. Once your account gets set up, click on Support Tickets tab, which is the feature we will be investigating for weakness. Okay. Now try creating a support ticket by clicking the green ticket button. Let's just start with this. I'll open up this link on a new page, and let me quickly just create. Let me zoom in a little bit. I'll click on Customers. I'll click on Sign Up, and let me just use Hacker. And I'm going to use Hacker at hacker.com. I'm going to use password, just 6 letters here. Okay, hit sign up. and there we go. So this is where we're going to be creating a ticket and going to be exploiting some of the XSS vulnerabilities. So let's continue. Now try creating a support ticket by clicking the green create ticket button. Enter the subject and content of just the word test, and then click the blue create ticket button. You will notice your new ticket in the list with an ID number, which can click to take you to your newly created ticket. So let's quickly do that. I'm going to click create new ticket. Over here, I'm just going to test this as test. The ticket content, I'm just going to use this as test as well. And I'm going to hit create ticket here. Once you're done with that, you see our ticket is ready. So to view our ticket, if I click on this part, number 3, we get the information about our ticket, which is the status, right? Okay, now like task 3, we will investigate how the previously entered text gets reflected on the page. Upon viewing the page source, we can see the text gets placed inside a text area tag. Okay, let's quickly do that. Ctrl U. Scroll down. Let's scroll up. All right, over here, yes, text area class form control text area. So you see in between the two text area, this is where we actually see our text here. All right, so let's continue now. Okay, let's go on. Now let's go back and create another ticket. Let's see if we can escape the text area tag by entering the following payload into the tickets contents, which is this particular area. Let's go back and let's just go back to dashboard and no tickets, create tickets, and this time I'm going to use test, and the contents, tickets content, we're going to use the text area test, and let's see what happens. Paste this here, create ticket. Once you click on 4 here, you see, wow, we see that the text was outside. All right, this shows us like it's working, right? Let's continue. Now again, opening the ticket and viewing the page source, we've successfully escaped the text area tag. To do that, we'll Ctrl U. If we zoom in a little bit, scroll down a little bit, you can see here that it did work. We did override that. Okay, now yes, so we successfully escaped the text area tag. Let's scroll down. Now let's expand on the payload to see if we can run JavaScript and confirm the ticket creation feature is vulnerable to an XSS attack. Now try another new ticket with the following payload. I'm going to copy this payload here, and when you view the ticket, you should get an alert box with its string THM. Let's try that. Close this and go back to tickets, create tickets. I'm just going to use this as test. Alright, and put this text area script alert to the THM create ticket. Once I've done that, once I click on that ticket right now, we did get an alert. So which means this did work. It did work. Let me see Ctrl U, scroll a little bit, and let's see how it looks like. Yes, perfectly alert. Okay, then let's go on. Now we're going to now expand the payload even further and increase the vulnerability impact. Because the feature is creating a support ticket, we can be reasonably confident that a staff will also view the ticket, which we could get to execute JavaScript. Now, some helpful information to extract from another user would be their cookies, now which we could use to elevate our privileges by hijacking their login session, right? Now to do this, our payload will need to extract the user's cookie and exfiltrate it to another web server of our choice. Firstly, we will need to set up a listening server to receive the information. Using the attack box, let's set up a listening server using netcat. If you want to listen on port 9001, we issue the command nc-l-p9001, and the -l option indicates that we want to use netcat in the listening mode, where the -p option is used to specify the port number. To avoid the resolution of hostname via DNS, we can add -n. Moreover, to discover any errors, running netcat in verbose mode by adding the -v option is recommended. Now the final command becomes nc-n-l-v-p9001, equivalent to nc-nlvp 9001. So we're going to start that. I'm going to go over here in netcard listening here and see. I'm just going to use 9001 as used there. If we open that, so it's basically listening. Now let's go back and continue. Now we have set up the method of receiving the else filtrated information. Let's build the payload. So the payload will look like this. Now let's break down the payload. The text area tag closes the text area field. The script tag opens an area for us to write JavaScript. The fetch command makes an HTTP request. URL or IP is either the THM request catcher URL, your IP address from the THM attack box, or your IP address on the THM VPN network. Now, port number is the port number you're using to listen for connections on the attack box. And cookies. Query string cookie equals to is the query string containing the victim's cookie. BTOA command base 64 encodes the victim's cookies. Document.cookie accesses the victim's cookies for the ACME IT support website. And then the last script here with the / after the left arrow closes the JavaScript code. Now create another ticket using the above payload. Make sure to swap out the URL or IP with the port number variables with the settings. Make sure to specify the port number as well for the netcard listener. Now wait up for a minute and you will see the request come through containing the victim's cookie. Note, you may encounter issues with receiving the request using your own VM and the VPN. It is recommended you use the attack box for these tasks. I got that late, but let's see. You can now use base 64 to decode this information, giving you the necessary input to answer the below questions. So I'm going to just try that and let's see if it works. Although I do have the open VPN, I'm going to open the attack box here. I'm just going to use the attack box. I'll let my ego win. So open the attack box once our attack box is ready. Okay, so I have my attack box ready. So I'm just going to quickly open up a terminal here, and I'm going to create the nc netcard-nvp. I'm going to use 9001. Enter, and I'm going to go back to create a payload, but this time I'm going to change the URL or the IP to the IP address of the attack box. So I'm going to come back here, create a new ticket, open here, and over here for the IP, I'm going to go back here and copy the IP address here. Let me see if that works. Okay, so I copied that. Let me see if it pastes correct. So but this is not dash, okay, dot, okay. Now the port number still remains 9001. So I think everything is complete. We have the attack box of the IP address of our attack box, and we have the port number 9001. So here I'm going to use, I'm just going to call it test. We're still using the text, and I'm going to create tickets. And once I've done that, let me click on that text and let's go back to our attack box. And yes, we did get a request back. Yes, so we did get our cookie back. So basically we're going to copy that cookie and then use the base 64 decode.org to convert that. So the cookie started from here, right, up onto the double quotation or double equal mag, and let's copy that. And let's decode that quickly and see. Paste here, decode, and let's see what happens. Staff section equals to this. Ctrl C. Come back here. What is the value of the staff section cookie? Paste that, and that worked. Ooh, okay. So I'm going to remove that as well. Let's see. Great. Okay. All right. So that was the end of it. It was quite an interesting room, the XSS vulnerability room. It was interesting. Thank you for studying with me. I'll see you guys in the next video. And for command injection, do enjoy the rest of your day, and ciao.